Welcome to part 2 of the recursion video series. To understand how recursion works, you need to understand how stack frames work. And to understand how stack frames work, you need to understand how stack and heap works. So today we will walk through an example where I'll explain to you how stack frames and then stack and heap works. So in this example, I have two classes, city and road. And I'll be using it here where I'll be creating two cities and creating a road and setting the from city and to city for the road. So the city class has just two variables, latitude and longitude, both integers, and the road has a from city and a to city. So for the city class, I'm setting these fields in a constructor, but for the road class, I'm setting the from city and to city using methods. So this is the calling code. This is Java code. So in Java, you'll also have a string array called args, but just to keep the example simple, I skipped that. So in the code, I'm creating a city, creating another city, creating a road, and setting from and to for the road. So when you call a method in Java, the first thing it does is it sets aside space on the stack called stack frame. So this is where it starts getting interesting as far as recursion is concerned. It creates a space called stack frame. Stack goes from bottom to top, heap from top to bottom, but for now that's not very important. It sets aside space in the stack for the method. Okay, every method call there is a space set aside. In this case, the method being called is main. We have space set aside for the main method. So once it creates a stack frame for the method, what it does is it assigns space for every parameter passed into the method, in this case none, and every parameter declared in the method, in this case C1, C2 and road. So you'll have space set aside for C1, C2 and road. Now it comes to the first line of code. First line of code, you're calling a constructor. You're doing city C1, you go to new city, and when you call a constructor, calling a constructor is basically like calling a method, because constructor is a method. So when you call the constructor, you're calling a method, and like I said, when you call a method, the first thing it does, it creates a stack frame for that method. So now again for the constructor, so this one was for main, this is for the constructor. It sets aside space on the stack called stack frame. And now let's look at the method. This is the method. So what did I say? It will set space aside for all the parameters passed in and parameters declared. Nothing is declared here, but there are parameters passed in, which is latitude and longitude. So it sets aside space in the stack frame for latitude and longitude. There is also another parameter that goes on the stack frame for instance method called this. I'll get to this later. For now, ignore this parameter. So it sets this, and now what did we set this to? Latitude is set to 10, longitude is set to 20. Okay, now you call, when you say new, you're basically creating a reference object, and like I said in the previous lecture, that gets created on the heap. So it sets aside space on the heap like an overhead for that instance object. Then what it does, when you create an instance of an object, it sets aside space for every single variable declared in there. So in this case, latitude and longitude. So it sets aside space for latitude, it sets aside space for longitude, okay? And now, when we execute the method, it sets latitude to the latitude passed in, longitude to the longitude passed in. So this is the passed in latitude, passed in longitude. So what did we pass in for latitude? 10. And for longitude, 20. And then this method returns. So when the constructor returns, it returns the address where the object was created. So which is this? So this is the hexadecimal address location. I mean, the actual location would be much bigger, but just to keep the example simple, I took smaller address numbers. So this will return this address location where the object was created, which is 0000. So before it returns, this thing pops off the stack. When a method finishes executing, it pops off whatever was created off the stack. So anything in the stack this is a critical point for recursion. Anything on the stack frame is only accessible when that stack is active. When it's gone, it's gone. So if you have 10 stack frames, it gets till here. There's no way you can get items what was there in the stack above. So this is all gone, and it returns the address where it was created. So which is 0000, and where whatever it returns is assigned to C1. So C1 holds the address where it was created. Okay, again for C2 the same thing. You create a stack frame, you have space set aside for latitude and longitude, and this variable. Latitude is 50, longitude is 100, and then when you call new, it sets aside space, some overhead for the class, and sets aside space for every variable in the class, which is latitude and longitude, which we saw earlier, like here, latitude and longitude. And now when we execute the code, it sets the latitude to the latitude passed in, longitude to the longitude passed in, which is 50 and 100. Okay, and now this pops off the stack, everything here is gone, and it returns the address, which is 0003, assigns it to C2. 0003. For road, again, when you create a new road, call the constructor new stack frame. There is only this parameter passed in. It sets aside, when you're calling new, it sets aside space and overhead. There is sets aside space for the parameters, which is from and to. From to returns, this is popped off the stack. Whatever is returned gets assigned to road. So which is 0006. 06 assigned to road. Okay, now an interesting part. You do road dot set from. Okay, you're calling a method. Stack frame. Set from. This is set from. Like I said, set aside space for every variable. There is a space for from, and there is also a secret variable called this that gets passed into every instance method. So I told you we'll get to this later, so we're getting to this now. So anytime you call a method on an instance of a class, that method gets a secret parameter called this, which points to where that class is located. So in this case, road is the instance I'm running, I'm calling this method on, and we know road is at 0006. So this gets 0006, and then what we pass in is C1 is what, we pass in from, which is C1, which is 0000. So we pass the city C1 0000, and a secret parameter called this, which points to the location of the instance where this method is being called. So we are calling this on road, which is at 0006. So that gets passed. Okay. And now we execute this line of call, this dot from equal to from. So this is 0006. So we know this guy's from has to be set to the from passed in. So this guy's from, which is this, gets passed to the from passed in, which is this 0000. Okay. Method returns. In this case, it's not returning anything, it returns a void popped off the stack. We call the next method set2. Again, create a stack frame. Set2 has only one parameter passed in, which is 2, and a secret parameter called this. This points to the road, which is this, which is equal to 0006. 2 is what we pass in here, C2 is 0003. Okay, now we say set this dot from equal to the from passed in. Sorry, we are in here. We say this dot 2 equal to 2 passed in. So this we know is 0006 here, and set his 2 to what is passed in, which is this. So 0003. Okay, this returns, popped off the stack, everything gone. And now this is also done, everything gone. Program finishes execution. So this is pretty much how static frame works. So some things to notice here is, for latitude and longitude, you're actually storing the values, okay? Latitude and longitude. But the road method itself has a reference type, These are not primitives. So these are primitive types. So primitive types, it holds the value. But these two are reference type where you hold the address. So basically address means this is practically a pointer to this location. That's what it is. And similarly 2 is practically a pointer to this location. So this is a very critical thing to remember, that all reference types are pointers to a memory location, and this makes a difference when you make when you solve recursion problems, because if you have to return an integer, you have to return it from every stack frame to the previous stack frame to the previous stack frame. But then say you're modifying a list or something, so in that case you don't have to return anything because they all have access to the same memory location. So suppose you had list here, they all will have access to the same memory location, so they can all modify that same memory location, and the last one will have access to that location. But if it is returning an integer or something, it has to be returned from stack frame to stack frame to stack frame. So we'll go into more details on, I'll be covering more examples where I'll be walking through how the stack frames work. But for now, this will give you a good high level understanding how stack and frame heap works. So that's all I needed to cover for today's lecture. Thank you.